Okay, we're good. Brilliant. All right then, so hello everybody. My name's Steve. I think I know a good proportion of you, but for those of you who I don't know, I've worked at Microsoft for like 5 years or something like that. I've been working on web stuff the whole time. And until about 6 weeks ago, I was working on the Azure Management Portal, which is a massive single-page application, which I'm sure virtually all of you have seen or used. And that was a really good experience. So I was doing that for about 2 years, and we built one of the biggest single-page applications that I know of. Like, it's really, really massive. There are hundreds of people working on it, and you know, it's a big, big thing. And so I learned a lot from that. And then 6 weeks ago or so, I took the opportunity of moving back to the original team that I joined when I came into Microsoft, which is ASP.NET. Yeah, bring it. And so the idea here is let's make ASP.NET the best platform there is for building really rich client-side applications. And from my point of view, I really want to bring some of the lessons that have been learned from working on Azure Portal and roll them into the core framework so that you can all benefit from them. So I'm going to show you a load of stuff today that you will not have seen before. For me, the slightly more nerve-wracking aspect of it is that also the rest of the ASP.NET team have not seen it before. And most importantly, my boss has not seen it before. So if at some point during the talk, the rest of the team rushes down and sort of drags me off and starts shouting things like, "You idiot, that's commercial suicide," then you'll understand what's going on there. But if that doesn't happen, then I'll just keep going. But seriously, the stuff I'm talking about today, there's no guarantees that it's going to be a thing. This is early ideas, okay? And whether or not it does become a thing depends on, in part, how you feel about it and how you react and whether you care about this sort of thing. Okay, so what is it like to build client-side applications on ASP.NET today? Well, I'm doing a few slides, but it'll be mostly code. Okay, so doing a single-page application on ASP.NET today, we've got some facilities that are really good and helpful, and then there are some things that we're not doing quite so well just yet. So on the good side, we've got some pretty good support for NPM, Bower, Gulp, Grunt. You know, these things are all wired into the tooling that you're using today. And as you know, we've now got very good cross-platform support, which is absolutely critical for front-end web development, which is all, well, not very much of people at web conferences will not have a Mac. So it's pretty important that we have good support for that. Some of the things we're doing are perhaps a little bit behind the times. So the project templates that we ship for single-page applications today, you could probably drop the word arguably from that sentence up there. They do not reflect current tools or technologies. We definitely need to do some work on those things. And then some of the other things that we've done in the past are not really applicable so much anymore. Like, you know, all the system web optimization stuff that we have. That kind of reflects the way that people did things about 5 years ago. So we've got some way to go on that. So some of the things that we don't do today, but I'm trying to push us to do, and I need you to support us in telling everyone that that's important. Maybe some things that you didn't realize you actually wanted to do, let's start with. So running your client-side code on the server, really? Why would you want to do that? Well, we'll get to that in a second. Bundling and minification at runtime as opposed to at build time. Again, would you want to do that? Maybe, maybe not. I'll show you. And then some other stuff, like, you know, obviously updating project templates. And then some other stuff I've listed there that it might not even be very clear what the idea there is. Why would you want to have dependencies from a NuGet package onto NPM or Bower packages or something like that? Well, perhaps by the end of this talk, you might see there are scenarios where you want to do that. But I'll point out that no one I haven't even mentioned that to the NuGet team yet. So they might just be like, don't be stupid, that's insane. But we'll see.
So state today is ASP.NET 4 or 5 beta?
The state today being like today, as in what you can use. So 5 beta, 4, like just anything that we've published. Yeah. Okay, so those are some thoughts about the landscape that we're in today. But let's just focus now on a specific technology, or Angular 2. So we just had this very nice presentation from Brad and Jules about Angular 2. And yes, that's a big new thing, and we know that lots of people are going to use it. It's pretty clear that there's going to be a big market for that, and Google's doing a great job of marketing it, and there's a big community around there. So we expect that to be popular, and we want ASP.NET to be the best platform there is for writing your Angular 2 application. And in particular, we want to do some stuff that makes it better than choosing any other technology. So let me show you a little bit of code now. So let me switch over into VS Code, and I'm going to run an actual application firstly, and then I'm going to show you some code. So let me just kick off DNX Web. This is an ASP.NET 5 MVC6 application, which is going to host some Angular code. So let me just run the application, and then we'll look at some code that's behind that. So I'll go to localhost 5000. I will fix the font size. So when that comes up, all right, so you probably have seen this or something like this before. It's the famous MVC music store application, which we rewrite in every different version of ASP.NET that exists, plus some other technologies, because that gives us an opportunity to compare how easy or hard it is to write a stock application with different technologies. And I've written this in Angular 2 just now. So I'm going to show you a bit of that code, and then I'm going to show you some ways that we can make it better. Firstly, in terms of the functionality, it does all the stuff you'd expect. So I can navigate around. I can see these different albums. I can use client-side navigation backwards, forwards there. So although the URL doesn't look like it's got special client-side aspects to it, there's no hash in there. It is client-side navigation there purely, and we can do other things like we can list the genres, we can navigate around, blah blah, all the usual stuff. We've got an admin section with a big grid, a paged grid. We've got all the usual CRUD stuff, details. We've got edit, validation. We've got a simple tie-in with Bootstrap modal there. So all usual kinds of web application things, and it's built with Angular 2. So let me just give you a quick look at some code before we see some ways that we can make it better still. So how does this actually work? Well, firstly, you see these URLs here? They're just regular URLs as far as the browser is concerned, but it is client-side routing. So if I hit reload here, I want it to land back on the same page that I was on before. So that means I need to map basically all the URLs into my client-side application, since I'm not doing server-side routing. So what I've done in my project startup, where the routes are defined, I've used this slightly cheeky technique, could probably use a little bit of refinement, but basically I'm saying, let's define this route called spar fallback that maps all requests that aren't matched to something else, and we'll send them into the home controller's index action. And that can boot up the Angular application. And that's going to render this view, index.cshtml. And inside there, we're rendering a load of script tags. Now, actually, I could simplify this down all to a single script tag with a single system import, really, if I wanted to. So maybe I should tidy that up. But the important point is that all these things have to get loaded one way or another. And then we've got this app element here. Now, you know that app is not a real HTML element that means anything to the browser. It's also not something that's got any particular meaning to Angular either. It's just an arbitrary name that I've given for my application entry point. So how that actually gets kicked off is, you see we're referencing this Bootstrap script here. And if I look in here to find my Bootstrap script, it should probably be renamed to boot or something to avoid confusion with Bootstrap, the CSS library. But anyway, what it does is it uses Angular to bootstrap my app, and it tells it that I want the root component to be this app here. So I'm giving you a very, very quick sort of sense of the way that the Angular 2 application is structured, but I'm not going to give you a full Angular 2 tutorial here. So the parts of this you don't understand, you can ignore, but I'm just giving you a quick sense of the end-to-end thing. So Angular tries to bootstrap this root component called app, and that gets loaded from this file, app.ts here, and that uses these decorators to say that this should be associated with an element called app. So when Angular sees that app element in the page, it will say, oh yeah, that matches up with the application root component, so I'm going to instantiate one of those and stick that in there. And then the client-side code here defines all of the client-side routes. So for all these different URL formats, we'll choose which component to get injected. So for example, if you want the root URL, we'll inject the home component. And if we want to look at the code for that, then I will bring that up, home.ts, and you'll see what that does is it takes an HTTP service instance using Angular's dependency injection that allows me to make HTTP requests. So I make a request back to the site into a web API backend to fetch a list of most popular albums and stick that all into an array called most popular. And then this renders the template for that component, which is this. And that's where this Jumbotron that you saw in the web page comes from. And it also uses Angular 2 view syntax to do things like iterate over all the albums, and for each one, we'll render an album tile component, which is yet another component. So we've got the app component, which contains the home component, which contains a set of album tile components, and it's just components all the way down. That's kind of the way it goes with Angular 2 and with most other similar modern web frameworks. Okay, so that's all very nice. And you may look at your application like this and think, okay, great, so I can build my complete application with Angular 2, make it as sophisticated as I like, and it's all running on the client. And if I do that, what value am I really getting from ASP.NET anymore? I mean, it's just serving these files to the browser. It's not doing anything else at all. I mean, couldn't I just replace it with a static file server? And nah, there may be some possibility of you doing that, but if you think that, then you're also significantly missing out on many significant benefits that you can get from having ASP.NET on the back end. And this is where I'm coming in and trying to find ways that we can add extra benefits to you. If you're using ASP.NET, we're going to make your life significantly better when you're doing these Angular applications. So what sort of things can the back-end server, that is the thing serving the UI, actually do to make the application behave better and to give you a better development experience? Well, let's think about performance for one moment. So notice that every time I hit reload, we see this loading message. It's on the screen for about 0.8 of a second or something like that. So that's not too bad. But that's when making a request against localhost. What about on a more realistic network connection speed? So I'm going to go and throttle the connection down to 4G speed here. So 4G is supposed to be reasonably fast, right? Well, what's the experience going to be like now? So if I hit reload and we get waiting, 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 and finally, here it comes. Okay, great. So that was not super fun for the end user to be waiting for that long. And partly that is because my application really needs to be bundled and minified a little bit. So I could probably drop that to like a quarter of its current size with some better build time work. But that's not really going to make that much difference because your application is going to be more than 4 times bigger than this anyway. So that's going to more than compensate for that. So what are we going to do to make it better? And in any case, even if you have an unbelievably fast network connection, that is, you're actually on the same machine as the web server, it's localhost, it's still going to consume a fair bit of CPU time. So let's measure that. I'm going to collect some JavaScript CPU time information here. So let's stop measuring that now, and we'll see how long did that take. Well, those of you who know how to use the current profiler better than me can probably give a better interpretation to all these numbers. But among other things, we're spending 500 milliseconds doing something called run, which I guess includes parsing all of the JavaScript that's come down, bootstrapping the initial application, creating the initial set of components, getting their initial data, rendering the initial UI, and pushing all that into the visible, into the DOM. So 500 milliseconds on an extremely fast laptop, what's that going to be like on an iPad 2 or a $50 Android phone? Not fun is probably the answer. And worse than that, okay, imagine this horror, your worst nightmare, right? What if someone doesn't have JavaScript on? What are they going to see then? Or, they've got no script extension, or they've got some sort of intercepting proxy that their 3G network puts up that mangles your JavaScript or something. What's going to happen? What's going to happen is absolutely nothing. The user's just going to see this loading screen forever, which is hardly a very compelling user experience. So what are we going to do about that? Well, if you were serving your application out of just a plain, a mindless file server, there would be nothing better that you can do. But you're not. You're building it on ASP.NET. So what can we do to make it better? Well, you heard Brad in the last session talk about Angular Universal and server-side rendering. And he said that it runs inside Node. What a shame. What a terrible shame that is for all of us in this room, that it runs on Node and we can't get the benefits of that. Or can we? Let's have a go, shall we? Okay, so I'm going to bring into my application a NuGet package that you won't have heard of before because it didn't exist until yesterday. So I'm going to go Microsoft. Do I have a network connection? Let's see if we can get a network connection here, shall we? Turn Wi-Fi on again. Right, let's try again. Microsoft, that's us, .ASP.NET, .node services, .Angular. Okay, interesting, right? What's this node services about? Angular? Okay, so let's use that, and hopefully VS Code will say you need to install this. It does, good. Click the restore button, that will do it. All right, so we've got this node services package. What that contains is some things that make it better for building, well, we've got the Angular package, some things that make it better for building Angular applications on ASP.NET. And one of the things that it contains is some tag helpers. Now, if you want to use a tag helper with MVC, then you need to go and register it. So I'll do that. I'll go into my view imports file here, and I will say that I want to add. Let's see. Can't do it while I'm zoomed in. All right, so I'm adding this tag helper. Install all the tag helpers from this NuGet package. Great. What can we do with these tag helpers? Well, we can go into this view where the app is, and I can stick an extra attribute on there. And the attribute that I'm going to add is this. ASP, get this Angular 2 application and pre-render it on the server. Okay, now it needs to know which JavaScript module the app component lives in. Why do we need to tell it that? Because normally the Angular bootstrapping process is implemented in JavaScript, but we can't get into the JavaScript until we've done the bootstrapping. So we've got a bit of a chicken and egg problem there. So we need to resolve that by telling it which JavaScript module to get the code out of. And I want it to get it out of that one. Okay, so it's going to come out of this file on disk. Okay, right, so I'm saving that now, and I'm going to go and I'm going to restart my web server like that, and then I'm going to go back into my browser when it comes back up, which is about now. And remember, I've still got JavaScript completely disabled in my browser. But I'll hit reload, and then when the server wakes back up again, which it will do pretty soon, then the application still shows up, even though there's no JavaScript there. Yeah, isn't that good? Okay, and what's more, I can still use it. I can navigate around. I can go, yeah, sure, let's have a look in here. We can see, there's a minor race condition issue there. And then we can, well, we can generally navigate around, but I do have, here we go. All right, so I'm going to go into edit, and I'm going to show you there's a bit of limitation here. So what we're doing here is we are running the Angular 2 application on the server, but we are just doing a one-time render of it. So every time I click navigate there, it's going back to the server and fetching the new page from scratch, a bit like with web forms or something like that, which means that I can do basic navigation like clicking on links, and that all works, but things that fundamentally are written in JavaScript are still not going to work because I don't have JavaScript. So if I click this delete button here, nothing's going to happen because that delete button invokes a JavaScript callback, and I don't have JavaScript, so that's not going to work. And similarly, I don't have any client-side validation. So we could do some stuff to make server-side validation work, and we'll talk about that. But really, although it's a cool party trick to show it working with JavaScript not on, a more important scenario really is when JavaScript is enabled, but the user just isn't on a particularly fast connection. So what's going to happen now is when the page first lands on the browser, it's all been pre-rendered on the server, but then the client-side code will load, and it will once the client-side code is loaded, then the client-side code takes over. So whatever stuff requires JavaScript, assuming it's enabled, will start working because the client-side application will pick up and become in control of what's happening in the browser there. Okay, so how much faster is this making things for us? Well, previously I made the argument that on something like a 4G connection, it could take a little while for the application to start up, or on a device with a slow CPU, it could take a while. How long is it going to take now then that we're doing server-side pre-rendering? Let's find out. I'm going to come and I'm going to reload this homepage here, and if we look at the network tab, we'll see it's taking about 73 milliseconds for the fully rendered application to hit, for the fully HTML-ified application to hit the browser, which is a pretty substantial improvement. Okay, but we can make it even faster still, Because remember, we don't just have a mindless file server on the back end, we've got ASP.NET, so we can use many of the very handy features that are built in there. So for example, let's say I want to make it faster still to get this application down to the client. Well, I could do something like this. Let's have a cache element. And I just want to say I want to output cache on a per URL basis the fully rendered application, just with a trivial bit of extra tag stuff added there. And now, when I come into my application, on a second time render, we're down to 3 or 4 milliseconds for... Yeah, isn't that good? So obviously, every time the user navigates, it's going... The very first time they hit any given URL... Well, that one was somehow really fast. Don't know how that worked. Let's try this one. One more time. So every time they come in for the first time, it's going to take a little while. We've got 100 milliseconds. But for subsequent requests, we've made it extremely fast. OK? So that is server-side pre-rendering, which is a pretty powerful thing that you could bring in. But let's just think about other types of applications that you're building. If you're building an e-commerce site like this one, to be honest, you're probably not going to build the whole thing completely end-to-end in Angular. You're probably going to do some server-side rendering as well. Let's just have another example of that. Here's a fictional airline, let's say, or not. And they, on this airline website, a lot of what they bring up is probably you would want to do server-side rendering. So everything that's not in this yellow box, you know that you could do extremely conveniently with regular MVC code, with its partials and Razor stuff. I mean, that would be really easy and convenient. And then just this stuff in the yellow box, you might want to bring in a big heavyweight tool. Sorry, I don't want to sound pejorative, but you might want to bring in a big, powerful tool like Angular 2 or React Knockout, whatever you like, and then use that for this part of the application. But what you don't want is to send this web page to the browser with a big empty box in the middle that says loading ... which then sits there for 15 seconds or something like that. You want to pre-render this part, and you'll drop the entire application in fully ready HTML into the browser, and the user can feel good about it. Now, you might be thinking, oh, that's all very well, but what if it does take 15 seconds to load and my user is trying to click on buttons or something during that 15 seconds? They're just going to get angry with me, aren't they? Well, the very nice thing that the Angular team is, or rather the contributors to Angular that are working on Angular Universal are making, is a JavaScript library called preboot.js. And that is a very small bit of JavaScript that you can send with this initial HTML. And what it does is watch for the user attempting to interact with the page. For example, clicking a button, changing a drop-down or something. And when they do that, it will put up a spinner over it to make clear that we're not really ready for that just yet. And then when the client-side code is ready and the client-side application boots up, it will replay whatever gesture they just did. And so, they can carry on. So hopefully in a good case, they don't even notice that that happens. But in a bad case where some problem with the network meant that they had to wait another 10 seconds, at least it's fairly clear to them what's going on. So you're getting the best of both worlds there. OK? That sound good? Any questions? No? Do you want us to do this? Yes. Yeah. All right. OK. Cool. All right. So let's open it up to something slightly broader now. I've focused on Angular there, but I don't only want to talk about Angular, and I don't only want to talk about server-side pre-rendering. Actually, a few more things about Angular, right? So I've just talked about pre-rendering. There's more things that we're talking about with the Angular team that we can do to make it better still. So one thing is cache priming. When I evaluated the application on the server there, it makes some HTTP requests back to itself to get the data that gets into that initial HTML page. Also then, when the application boots on the client, it's going to make those AJAX calls again to the server to get exactly the same data. Can you see why? Because the same code is going to run twice, essentially, and so it's going to make the same HTTP request twice. Now, that is not really what you want. So cache priming is a feature where we can automatically say, oh, the server-side code wanted to make these HTTP requests, so the client-side code is going to do that when it boots too. So we're going to include in the rendered markup some information to tell the client-side code, don't do those requests again. You've already got the data. Here it is. So that will make it a bit faster still. We're also looking at some ways that we can make forms and server-side validation flow through between the ASP.NET code and the Angular stuff better. And I don't think Brad mentioned, but I hope this is OK for me to say, that they are working with the VS Code team on providing really good IDE support. So in your Angular template, you should be able to get really strong IntelliSense in there. And then Brad did mention the Angular CLI pre-compilation thing. So we're looking at ways of integrating that into a sort of standard pipeline as well. All right, broadening this out now to things beyond just Angular and beyond just pre-compilation. So if you work in the front-end web development world at all, then you cannot avoid Node.js. Basically, all of the infrastructure that is widely available for things like pre-compilation, transpilation, basically anything you can think about in front-end world is written in JavaScript and is designed to run on Node. You can't get away from that. So you may think, well, that's a bit of a pain for me because I don't want to be messing around with Node all the time as well. Or rather, I'd rather just do one thing. So one of the things that I'm trying to push here is the ability for ASP.NET developers to be able to consume arbitrary functionality from NPM in just the same way that you can consume it from NuGet. And I don't just mean at build time, I mean at runtime as well. How do you think the server-side pre-rendering for Angular works? As Brad mentioned, that runs inside Node. So it was running inside Node just then, even though I was in an ASP.NET application. But I didn't have to do anything to make this ASP.NET to Node bridge work. It just happened there in the background. So how does that work, and what else could we do with that? So we're envisaging a possible scenario where you would have a set of NuGet modules, or packages, whatever we call them, that provide services for you for different client-side front-end technologies. So you might have one for Angular, one for React, one for other things that you like. Yes, for those of you who are interested, I do have an early prototype of doing the server-side rendering with Knockout as well. So all of these things could be packaged up in NuGet, and then all of them take a dependency on a common package called Microsoft ASP.NET Node Services. And that is a thing that knows how to start up instances of Node, manage the lifetime of it, and deal with communication with it. And in terms of how it communicates with it, well, that itself could be pluggable. And hopefully most people using it don't have to think about that, but we can make different trade-offs in terms of ease of use, robustness and performance and so on. And maybe you can plug in other ways of interop with Node as well. You could even, for example, have a transport that communicates with Node on a different server or whatever you want. Anyway, that's a sort of basic idea. And in terms of these different transports, I just want to give you an idea of the sort of speed, the performance that you can expect from this sort of thing, or to emphasize that we're thinking about performance from the beginning. So to give you a sense of scale here, a sort of unrelated thing, but it's relevant for scale, is how fast is a typical database query? So I just measured a request using, what is it called? Entity Framework, that's the one, through to SQLite running on my Mac here. And that was for a very simple query against a small database coming back in about 2.1 milliseconds. A completely different type of thing, but it just gives you some sense of scale. So how much overhead is there with making these requests through from ASP.NET into Node in the background? With the HTTP transport, which is what I used in the demo just then, I'm seeing about 3.5 milliseconds of overhead. We can make it a lot faster, though. I've got an experimental streaming-based transport, which brings the overhead down to about 0.2 milliseconds, which might well be fast enough that you're not worried about making it faster. But if you do want it to be faster, we can consider hosting Node in process inside your Node.NET application. It's sort of meaningless to give a number to that, but that should be extremely fast. But to be honest, 0.2 milliseconds may well be fast enough for you anyway. Don't worry too much about these numbers. I'm only showing them just to make it clear that we are thinking about performance from the beginning, and we have a plausible plan for it to be extremely fast. Okay, so it's not just for Angular. Let's show doing a similar thing with React. How many of you use React? A much smaller number than Angular, but nonetheless, it's a significant thing within front-end world, and I'm sure that number is going to grow over time. So let's do a demo with React now. So I'm going to switch projects over to this one creatively called React Grid. You can probably guess what it does. And I'm just going to start it up, and then I'll show you some code. So go to my React Grid example and get that started. OK, here it comes. And run that in the browser. And this is a very boring and simple application. It is literally just a grid. It's all completely client-side rendering right now, but it does support browser back-forward navigation like that through this grid. Not very clever, but it shows the basics. Now let's say that we want to enable server-side rendering for that. So just like I did before, I'm going to add a package. And this time it's going to be called nodeservices.react. Okay? And so that's going to get installed, hopefully, by VS Code. No? All right, I will do it manually then. Restore. Okay, so that's going to provide some facilities for React developers, obviously. But this time we're not using a tag helper. I'll explain why. Because React is a bit different. If we look at how our application works, on this occasion, it runs this index view, just like the Angular one did, and it's creating a div with the ID React app, with this loading message in it. And then the client-side code is going to inject the application into there. So let's see the client-side code. Here's my the place where my application starts. It imports all the React stuff. This is ES 2015 syntax. And it's using React to render an instance of the React app component. This is JSX. That's why I'm allowed to put HTML elements into the middle of my JavaScript. And we're saying render that element and stick it all into a DOM element called React app. And then the actual React app component is defined in this JSX file. So that's got a render method that defines the client-side routing configuration here. And that's going to invoke people grid. And here's my people grid. And that's going to use this griddle component. That's a standard React component for rendering grids. Okay, so I'm not going to talk any more about how React works, but that's the sort of quick outline. Now, if I want to do server-side rendering, it doesn't really make sense to put some sort of a tag helper here on this div element because we're not even talking about React at this point. All we're doing is producing just a bit of HTML markup. We don't even start talking about React until we get into this JSX file. So there are many different ways this API could work, and this is totally not settled because no one's even seen this besides us in this room right now, so we definitely appreciate your feedback on what the API should be looking like. But one way that we could do the React server-side rendering would look like this. I'll go into my home controller here, and I'm going to drop in a little bit of code that's going to invoke React rendering. So here, I'm using this static function called reactRenderer.renderToString, and that exists inside. No fixed suggestions, really. OK, let's type this out manually. Microsoft.aspnet.nodeservices.react. OK, and then this is asynchronous, so I'm going to mark it as async task of that thing. OK, so now that's going to tell my React renderer to use this node instance behind the scenes to render this React JSX file, and then we'll stick the HTML into a string that's going to go into view data here. Now I need to give that an instance of node services. Node services is basically the node instance itself. And in order to make that available, I'm going to go into my application DI configuration, and I'm going to say services.add node services, like that. And that is an extension method in that API, in that namespace. OK, good. So now I've added that to the DI config. I can put in a constructor. So public home controller, and I'll please receive an instance of inode services, which is in this namespace, node services. Okay, and then I'll say this.node services equals node services, make a field for that. Okay, and now all the compiler errors should go away. All right, and then finally, now I've got this view data React output. Here in my view data bag, I can go into the view and say, well, let's not display this loading message anymore. Let's now instead display something like this. I want to output that string without re-encoding it because obviously it's already some HTML there. So if that works, I can restart my application, and then I'll go back to my browser, and I'll hit reload. And we should see now, when it reappears, that just like before, we should have the same JavaScript is disabled, but it still comes up and the user can still navigate their way around it. Not that I really think people have JavaScript disabled, but just to make the point that it really is server-side rendering there. And if we look at the initial markup that's landing in the browser, we get all this disgusting looking stuff, which is the initial stringified representation of the application UI. So that is a slightly different pattern for doing the server-side rendering. And as for which of these approaches we focus on more, kind of want a bit of your feedback about that as well. But anyway, that's just to show you that we can do this with React as well. And of course, we could do it with other technologies too. OK, now, once again, I want to broaden the discussion a little bit further. So beyond just Angular, beyond just model view frameworks. But what about other NPM stuff? So NPM is probably the biggest package repository that there is across any technology. It's an absolutely massive supply of some really high quality stuff. And if you are working in Node, then you can trivially just bring in any of that and benefit from it at runtime. So wouldn't it be nice if, as ASP.NET developers, we could also pull in arbitrary things from NPM and benefit from it, not just in our gulp scripts at build time, but at runtime just as easily as well. So that is where this Microsoft ASP.NET Node Services package comes in. So this is not specific to a particular JavaScript framework. This is just about working with Node on its own. Let me show you an example of that. So I'm going to switch over to another example now. This one is called ES 2015 Transpilation. So you can probably guess what it's going to do, but let me start it first, and then we will implement some code here. So go in here, DNX web, get that running. Very good. Okay, so this is an even simpler application than the very simple React grid one. Let me show you what it does. So I'll come in here and hit reload. Okay, and let's see what's happened. It just displays hello. That's not very clever. But what is way more clever, and hopefully going to make me some billions, is that it emits a hello world message to the console there. All right, so how does it perform this extraordinary technical feat? Well, let's see. Inside my main index page, you'll see it uses System.js, which is a JavaScript loader. It's a modern way of loading JavaScript. It's got a lot of advantages that I won't talk about. And it's loading this JavaScript file called main.js. And inside main.js, let's see what we got. We've got the secret source for my unicorn startup, which is console.log, and that sends the message down to the browser. Very good, okay? But if I am going to manage to recruit some investors to my billion-dollar business, I'm going to have to be able to reassure them that I'm building my application with the latest technologies, okay? So I'm going to want to write this with ES 2015. And in fact, I've already written a prototype of my application here. Or rather, I've created this class called Greeting. This is ES 2015 code, if you're not familiar with it, the new version of JavaScript. And it's got this get message method, which returns a string. And if I want to consume this from my application now, I can rewrite main.js using ES 2015 code here. So I'm saying I want to import that greeting module, and then I can new up one of those and get a message from it before logging it to the browser. Okay, so that's ES 2015. Is it going to work though? Let's find out. I'll come to the browser and I'll hit reload, and no, it does not work. Why doesn't it work? Well, first reason is because it's completely confused System.js into thinking that I want to load Tracer for some reason, which I didn't. But also, even if it didn't do that, it still wouldn't work. Why? Any suggestions? Because my browser doesn't support ES 2015. It's just the current version of Chrome. So it's only going to support ES5 and below code. So if you want to run ES 2015 in the browser, you know that you have to transpile it. So you have your gulp script or something that's going to transpile back to ES5. Okay? So a very common way of solving this problem is to set up a build time transpilation step. But then you have to think about, okay, now I've got to write my gulp script, I've got to configure it to do the transpilation, to put the transpiled output into some sort of dist folder, then I've got to maybe exclude that from source control, but somehow still make sure it's there on the production server, and I need to remember to clear it out if it gets old in some way, and I have to remember to point my code to the dist folder instead of the source folder, and probably other things that I can't remember. So there's a lot of things you have to think about there. Wouldn't it be nice if you didn't have to do any of that stuff? If you could just send main.js as it is without having to do any build step first. So I'm not saying you shouldn't use grunt or gulp. I'm just saying it's nice to have options, okay? So let's use our option of using Node at runtime to do runtime transpilation here. I want to catch requests for JavaScript files and on the fly convert them into ES 2015. So I can do that by using a bit of middleware. So this is an ASP.NET 5 application, so I can come in here and I can say, all right, as part of this chain of middleware, I want to catch all requests for JavaScript files. Here we go. Right, so here's my outline of some middleware. I'm not using any Node code here. This is just .NET. I'm saying, okay, catch all requests. Have a look at the URL and see if it looks like the sort of thing I want to transpile. Also check, if it is, does that really match a file on disk within my www root folder? If it does, then I'm going to want to transpile this thing. But all I'm doing just now is emitting this message, you requested request path. If any of those things is not true, then we'll just allow other middleware to run. So let's try that, shall we? I'm going to restart. Does anyone have DNX Watch working on a Mac yet? Anyone? No? I couldn't make it work. So whoever's responsible, please fix that, okay? I'm going to have to keep stopping and restarting my application. So now I've got this middleware in here. Hopefully it will catch any requests for JavaScript files and replace them with this message, you requested whatever it was, okay? So now I want to plug in a bit of code to invoke Node to do some runtime transpilation. And I can do that by referencing the Node services package, which I've already referenced here. And then I can go into my startup file and I can say, okay, I want to add Node services to the DI config, which means that I can receive an instance of Node services wherever else I'm using DI. Okay, and when I've got that Node services here, I can use it. So I can say here, in the middle of my middleware, I'm going to say var result equals await node services dot invoke, and now I give it the path to a JavaScript module on disk somewhere. Let's call it transpile.js. I could call it anything, that's arbitrary. And then I can pass some parameters to it, whatever I want to pass. Let's say I'm going to pass to it fileinfo.physicalPath, so that it knows what file I want to transpile. And then instead of displaying this silly message, I'm going to display result. All right, let's try it, shall we? So I also need to create this file transpile.js. Now, it doesn't have to be in the root folder, but in this case, I will put it there. So new file transpile.js. And then I can write arbitrary node code in here. So I'm going to put a very simple sort of hello world thing in there for now. So I'm exposing a JavaScript function which receives a callback so I can do asynchronous things. And when I'm ready, I'm going to send it back this message, hello from Node. Okay, very good. Right, so let's restart my application, annoyingly, again. And then when that comes up, I will hopefully see, instead of this silly message, it will now make a call into Node, and it'll come back with this hello from Node message. Okay, let's see how fast this is happening, shall we? Let's reload with the network tab open, warm the cache a little bit. Okay, so if I press it enough times that give me a result that I like, we'll see that it comes back with about 6 milliseconds on this occasion, compared with about 3 or 4 that I'm finding if I don't have this step of waiting for Node. So this is where my figure of it adds about 3.5 milliseconds of overhead comes in. But as I mentioned before, there are faster transports than the default one that I'm using. So if I wanted, I could go to where my Node service is configured and say, let's use node hosting model.input-output stream. Okay, let's see if that's any faster. So we'll restart again, and then when it comes back up, we will compare the performance. Here it goes, reload, and then after a few requests, we're down to between 2 and 4 milliseconds. So basically, no overhead compared with just the basic .NET code, or, you know, we're talking certainly less than half a millisecond, and we can probably make it faster still. So you may be thinking, well, why wouldn't I always use that? And the answer is just that it's not ready yet. It's got all kinds of bugs and problems with it. So that's why I'm using the HTTP transport right now, but obviously we will make that a little bit more robust if we go forwards with this. Okay, so getting back to that. Okay, now let's make this actually do something better inside Node. So I'll go to my Node code here. And remember we were passing the physical path in from .NET code. Physical path. So I can say, you requested plus physical path, and I hit save, and this time I don't have to restart because Node will say, oh look, you've just changed this file that I was using, so I'll just restart the Node process, and now my Node code is, updated. We know what file we're requesting. Let's do the actual runtime transpilation here. I'm inside Node, so I can use any NPM module that I want. It is just Node. So let's use Babel, which is a library that can do transpilation for me. So I'm saying, firstly, I'm using Node to get the file system module so that I can read that physical file from disk into a string, and then I'm using Babel to transform it into ES5 code. Okay, let's see if it works. Come back and hit reload. And now, hopefully, I will get the actual transpiled code in my browser without having to have gone through any compilation step or have any temporary files on disk. And if I come back and reload my actual mega application here, you'll see that we now get this hello from the AS 2015 class because all of the requests for JavaScript have now been transpiled on the fly. And obviously you could wrap whatever kind of output caching you want around that so that there was basically no meaningful performance overhead if you wanted to. So I am not saying that you shouldn't use gulp or grunt for runtime build stuff. There are a lot of advantages to that, and I think in a lot of cases that's still going to be a better choice. I'm just saying it's nice to have options, right? It's nice in general to be able to pull in whatever you want from NPM and just use it as part of your ASP.NET middleware with very little friction. There we go. Let's summarize this. Our goals here, on one hand, and most specifically to be the best platform there is for building Angular 2 applications. And so we are working hard to make sure that all the good things that Angular 2 can do, like server-side rendering, will be seamless inside ASP.NET. And then we're also working on a bunch of other features in collaboration with the Angular 2 team to make sure that the interoperation between the server and client is as smooth as it can be. A little bit more generally than that, we want to be able to enable ASP.NET developers to use whatever they want from NPM at runtime. Or I say we want to do that. I'm trying to persuade you and everyone else at that time. So we want your feedback about how useful this is and what you would do with that. And then finally, if we can make a relatively standard way of doing that, that could allow an ecosystem to grow. So if you want to build some kind of NuGet package that does something funky with Node at runtime in an ASP.NET application, you can build that onto this Node services package, and you will then know that other people would feel confident that you've got the robust interoperation with Node there. So that is it. I think we are into your break time now, so you can ask me questions, but we're also into your break, so you should also just stand up and leave if you want to go and get drinks. Okay? Any questions?
What's in that Node Services package?
What is in the Node Services package? Not a lot. Do you want to see it?
Magic and unicorns.
Yeah. No, it's not very difficult. So I'll show you the Node Services package source code. This is, it's not public on GitHub yet, but it probably will be within a few days. So the Node Services package is here. So inside the Node Services package, we've got a bit of .NET code that deals with all the different .NET the hosting stuff for Node. So that is capable of launching Node in various different ways, managing its lifetime and doing communication with it. And then we've also got a very simple bit of Node script that deals with receiving the requests from .NET World and passing them on to your own Node modules. And that,
You need Node installed on the machine.
you do need Node installed on your machine to make this work, yeah. I mean, we could actually package the binary in there if we want to, but I'm not sure how much people are going to be happy with us doing that. Any other questions? Sorry, yeah? Is the music store for Angular 2 on GitHub somewhere? It is, but it's private right now. I don't see any reason why we can't flip that over to be public. Hopefully we can do that for you within a few days. Anything else? Yeah. 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 Yeah, okay, so the question is, if it's not limited to just Angular and React, how exactly would someone else come in and create a package that works with something else? Well, very simply, you just make your NuGet package, take a dependency on Microsoft ASP.NET Node Services, and use the API to make calls into your own JavaScript that deals with whatever Node thing you want to do. In terms of documentation, yeah, sure, we would document anything that we ship, absolutely. Anything else? No? All right, great. Well, have a good break and enjoy your day.